Okay, we did the learn some matrix operation. So we know something about a matrix. A matrix just you put the numbers in certain rows and columns and make that even, and then you can go ahead and perform a lot of operations. You can add, subtract, and multiply. Today, right now, our topic will be matrix solutions to linear systems. What does that mean? That's how do we use matrix, okay? So matrix solutions to linear systems. All right. Now I give you one example. I use this example to tell you what I mean, okay? So if you want to solve a linear equation or linear system of linear equations or linear system, is the same thing. So you have, for example, I give you 2x plus y plus 2z equals 18. And I have x minus y plus 2z equals 9. And then the last one I have x plus 2y minus z equals 6. Based on what you learned earlier, you know how to solve this type of problem because you can just choose two pairs of the equations and work with them to eliminate the same variables. So you're going to go to two equations with the same two variables, and then you can pretty much you drop it down to like a two equation, two variables, and then you can use either graphing method, which you don't like to use, I don't like to use, or you can use the elimination method or substitution method. You can choose either one to work it out and then to find out the solution and then go back and at the end you can always bring your solutions back to the answer, to the equation to check your answer. Now we're going to learn something new. We are going to use matrix. So let me see. The first one, I'm going to write this in this form, in the matrix form. So instead of having all those x, y, z, so this is for like a lazy people, I think. So I'm going to put 2 and a 1 and a 2, and I put a vertical bar and I put 18 on the right. Okay. Okay. So this is called augmented matrix. I have 1, -1, and a 2, and a 9, and I have a 1, 2, -1, and a 6. See? That's what you're doing. That's easy, isn't it? I think everybody can do it. As long as you make them looks like this, line them up, so it's very easy to put here. If you don't have this x term, then you just put a 0 here, okay? So make sure that the first column is for x, the coefficient of x, coefficient of y, coefficient of z, and this is a number to the right of equal, and this is the first equation, second equation, and the third equation. So that's your first step you got to do, all right? After this, okay, I tell you what I want to have. I want you to do, okay? What I want you to is to perform, we call that row operation. Row operation, which means I will perform the operation by row. For each row, I have to take everything with me. So I will do this row with this row and this row all together. So I cannot just do something to 2 but not the others. No, I have to do that by row. So what I do is I prefer to write row 1, row 2, and row 3. Okay. Looks good so far? All right. Now, I will perform the row operation. I tell you my first goal. Actually, my first goal is the first major goal. I'm going to break that down into a lot of little goals. But actually, the first goal is I want to have here is 1, 1, 1 at the diagonal. And here's a 0, and here's the numbers, and here are numbers. That's my first goal. So I need to have things looks like this. All right. I tell you what should I do first. This is your first step. I always want to have the first row, first column number to be 1. All right. If that's my first goal, I notice that there's a 2 here. What I can do is I can divide it by 2. Remember, whatever you want to do to this guy, you have to do the same thing for the whole row. But here's a 1. I don't want to divide it by 2 because I want the whole number. Okay. However, when you do the row operation, there's a one row operation, it's a switch, which means you can switch row 1 and row 2. If you want, you can do switch row 1 and row 2. Okay, so what do you have? After you switch that, you're going to have 1, -1, 2, 9, because you switch this. Now you see why I call this row operation, okay? And the last row, I'm not changing it, so just keep it. So that's my first step. Done, right? My first step. See, I got that. All right. My second step will be, my second minor step will be to get this two guys to be 0. Okay. And I have to do this one by one. I cannot do them at the same time, so I have to do this one by one. Then how do I make this 2 to be 0? I'm going to use the one I already have. So again, I call this as R1, R2, R3. Don't worry, already switch it, so we'll always start from the new one. So what I will do is I will go from here, use this one, multiply by -2 and add to that. This is the row operation I'm going to perform. So I'm going to go row 1, multiply by -2, and then add to my row 2, becomes my new row 2. So the first row, I keep it. So I have a 1, -1, 2, and a 9, okay? So that becomes my new row 2. What I do is, you can see I use R1 times -2, and then add to that becomes my new row 2. So 1 times -2, which is -2, I add to this, I got a 0. Did I get 0? Yes. And don't forget, you have to do everything, okay? You have to do that to all the numbers. So -1 times -2, which is 2, plus that 1, you get a 3. And then 2 times -2, you get a -4, plus 2, you get a -2. And then 9 times -2, which is -18, plus 18, you get a 0. Okay? And then you want this guy to be 0. So what you're doing is you use your R1, you're using the one you already have, okay, times -1, and then you add to R3. That becomes your new R3. So which means you're using this one, multiply by -1, add to it, ding. And this one multiply by -1, you get a positive 1, add to that. This one times -1, which is -2, so you get a -3. And here you times -1, which is -9. -9 plus that, you get a -3. That's my new R1, R2, R3. So my next step, I'm going to base on this, okay? So far, I finished, where's my, see, I finished this, right? Am I good? Okay, so I'm done with that. I'm going to finish this. Okay, so what is my next job is to get this one to be 1, okay? And I want that to be 1. I notice here, here's a 3, and here is a -2. If I divide it by 3, I will get 1. And here, if I divide by 3, I get a -2/3. That's not good. But I noticed the last row. Did you see the last row? You think in your mind, what is actually is? That is a 3y minus a 3z equals -3. Can you divide it by 1 at the same time? Yes. So I will do, I keep the first one because I already got it, so I'm not changing it. And then I keep the second one, second row. And then for the last row, I will use my previous row 3 divided by 3. Then I will get a 1, -1, and a -1. So that is my new R1, R2, R3. Okay, so that goes to here. All right, now at least I have a 1 here. If I switch these two rows, then I'm ready to put this 1 here, okay? So what I'm going to do is I will switch R2 and R3, which is just the previous one, okay? So the first one I keep the same, and I switch this two. So I'm going to write 1, negative 1 here, and I'm going to put 0, 3, negative 2, and 0. So that is my new R1, R2, R3. Phew. See, this job is done, this job is done, this job is done. My next job is to put here to be 0. How do I make that to be 0? I'm going to use this guy. This is 1. Multiply by negative 3 and add to that. So I'm going to keep the first two rows, so that will be 1, negative 1, 2. Be very careful, okay? So it's so easy to make a mistake. So it's a 0, 1, negative 1, negative 1, and this is my R2. And then my new R3 will be R2 times negative 3 plus my old R3. That becomes my new R3, isn't it? So I'm going to use this one times negative 3, add to it, I got 0. And this one, the good thing is I have all the zeros here, so no matter what you're doing with your R2, R3, this is always a 0. Now you see why I do this first, and I get all the 0 down below, and then I get this, so I just leave that here, I don't worry about the row 1, and then I'm going to start working on here, so I get a 1, and then now what I'm doing here is to get 0 here. And then here I'm going to use R2 times negative 3, which is positive 3, and then plus the negative 2, so I get a 1, and then negative 1 times negative 3 plus 0, which is a 3. That's my new R3. First goal is done. Once you finished, once you go to this step, this is called row echelon form. What do you have here is you already have z equals 3. You have a y minus z equals negative 1. You have x minus y plus 2z equals 9. That's what you have. So pretty much if you have that here, you're pretty much okay to solve the problem. However, usually I don't want to just stop there. Okay? When I am here, what I would do is I will continue to make here, here, and here. I will make them to be 0. Okay, how should I do that? The easiest one is to make this guy to be 0, isn't it? Keep going. Okay, so almost like every single question you will need like 2 pages. I will leave the first row as it is. 1, negative 1, 2, 9. And the last row I don't need to change because I already have a very simple thing here, R3. What I need to do is I need to get rid of this negative 1. See that? So how do you do that? You're going to use R3, add to R2. So your R3, you only need to times 1 because you're not changing that. Then you just add to R2 plus R3. That becomes your new R1. So this R3, R2, we just talked about the one right before. Okay, so that would be you add, that's 0. You add, it's still 1. See, that's the benefit that you have 0 here. When you do whatever up, it won't change anything. And this, you get 0. And the 3 plus that, you get a 2. So that's my new R2. Seems good, right? Okay. And then I want to get rid of this. How do you get rid of that? And you're going to use this 1 times negative 2 and add to that. So your new R1 will change, but R2, R3 will be the same. So let me keep that. 0, 0, 1, and 3. Okay, so these two are going to be the same, no change, but your new R1 will be the row 3 times negative 2, add to it. See here all the zeros, which means you use this 0 multiplied by whatever number is still 0, add to it, it won't change. So my new R1 will be R3 times negative 2 and add to the old means just the previous R1. So this times negative 2, this times negative 2 is all 0, so I still have 1, negative 1, and then this 1 times negative 2, plus that I get a 0. And this times negative 2, which is negative 6, plus that you have 3. Okay. So that looks pretty neat already, and there's only one thing that looks, I want to get rid of that. I need to get rid of this. How you get rid of that? You're going to use this one. Because see, all other places are 0. If you just add it to that row, then this will be gone. So your new R1 will be R2 plus your R1. That becomes your new R1. And R2 and R3 will not change. Okay? So see, you add this to that. So 0 plus 1, which is a 1, and that's a 0, and here's a 0, and here's a 5. So that's my new R1, R2, R3. Okay, so this is my second goal. Remember, the first goal is to get all the diagonal, one and all the lower triangle area all 0. My second goal is like this. I will get 1, 1, 1, all the diagonal with 1, and all here 0, and then the step 2 is get all here 0. Okay. All right, so you get this form. Then can you rewrite that back with your x, y, z? Because remember, I use the matrix because I don't want to write x, y, z. So this one is 1x plus 0y plus 0z equals 5. So you get x equals 5. You get a y equals 2. You get a z equals 3. Or the other way, you can say 5, 2, 3 is your solution, because it depends on what you would like to use as your answer, but they're the same thing. Okay, you get the idea. The idea is this. For the matrix, augmented matrix, if it's a 3 by 3 here, okay, I tell you what is your first step. This is your first step. You want to make that to be 1. And this is your second step. And this is your third step. You have to make this to be 1. And that is the fourth step. And this is your fifth step to make this 1. And then go back. Once you have this, then you go backwards. This is your sixth step to make it a 0, to make here 0, and to make here 0. So that's like an 8-step job. Then you can find every time you have to do the row operation, okay? Then you're going to find your solution. So can you remember that? Get the top left corner 1, and then make it down below all 0s. Of course, that you can break that into 2 steps. That's fine. And then you make the next one, the second row, second column, to be 1, and then make all the number down below to be 0. And then keep going until you finish till the right bottom corner of your the coefficient matrix to get here, and then moving backwards to eliminate all those numbers to make sure that everything you get here was 0. So the purpose at the end is to get all the 1s and you get all the 0. So you have the solution. Okay, so we're going to try one more question. Okay, this one just takes a little bit of exercise, and I want you to put a little R1, R2, and I hope if you could, you can just write a little note here, because in the future, if you want to go back to check your answer, then it will help you. Okay, it will give you big help. So let me do another one. X minus y plus z equals 8, and I get a 2x plus 3y minus z is negative 2, and I have 3x minus 2y minus 9z equals 9. Okay. So what do you think? I think it's bad, huh? All right, now we're going to write that in the augmented matrix form. So I have a 1, negative 1, 1, bar, 8. 2, 3, negative 1, negative 2, and I have a 3, negative 2, negative 9, and 9. And then I write R1, R2, and R3. What is your first job? the first job is to get the top left corner 1. And then luckily you already have it. You don't have to do any switching or division. You already have 1. So first job is done. Then the next job is to make the number down below here to be 0. So we can do that. I copy the first row because the first row I'm very happy about it. So that's 8. Okay. And how do I make this to be 0? I'm going to do the row operation. So I'm going to use this guy times -2 and add to it. So that is my row 2 times -2 plus my row 1 times -2 and plus my row 1. It becomes my new row 2. 1 times -2 plus that, I get a 0. And then -1 times -2, which is a +2, so I get a 5. Okay. And the 1 times -2, which is -2, and plus that I get a -3. 8 times -2, which is -16. -16, -2, I get a -18. Okay, so that's my new R1 and R2. And also I want here to be 0. I really want that to be 0. So I'm going to use this one, R1, here's 1, times -3, and then add to my old R3. So that is 1 times -3 plus 3 is 0. -1 times 3, which is +3, and -2 is 1. And then here's 1 times -3, -3, so that's -12. 8 times -3 is -24. -24 plus 9, I got a -15. So that's my new R3. Seems good, right? All right, so first job, 1, 0, 0, and the next thing I need to get here to be 1. But so far, like this one, I have a 5. I have a -3, -18. I don't want to divide it by 5. So I would like to switch R2 and R3 so I can have that 1 there easily. So let me write down -118. I keep the first one. I'm done with that. And then I'm going to switch R2 and R3. So I have a 0, 1, -12, -15, and then I have a 0 and a 5 and a -3 and a -18. So that is my, so far, that's my R1, R2, R3. All right, and you know the next job, I need to get here to be 0. So 1, 0, 1, 0. How do you get here to be 0? I'm going to use this one, multiply by -5, then add to it. So I would copy just the first 2 rows. That's my R1. And then this one is good so far. -15 is my R2. And my R3 is going to be my R2 times -5. Then plus my R3, that becomes my new R3. Okay, 0. Nothing. So 1 times -5, which is -5 plus 5, which is 0. Now this is tricky. Okay. -12 times -5, which is a +60. +60 plus a -3, I get 57. It's getting scared, huh? So -15 times -5, what do you have? -5, -15, you get a +75. And a +75 is +75 minus 18. You get a +57. That's my R3. It looks so scary. All right. Then you get a 1, 0, 0, 1, 0. You have to make this one to be 1. And it's very obvious that you just need to divide it by, you're going to use R3 divided by 57. Isn't it? So I have a 1, -1, 1, 8, 0, 1, -12, -15, R1, R2. If I use the whole row divided by 57, I got a 0, 0, 1, 1. Lovely. Halfway there. Keep going. I have to get rid of this. So I'm going to use this row times a +12, then add to that. So I keep the first row. 1, negative 1, 1, 8. I keep that. Row 1. I keep the last one. I love it because it's already done. R3. Now what I'm going to do for the row 2 is I'm going to use row 3 times 12, and then plus the row 2 becomes my new row 2. So all the thing here, you have a 0 times 12, a 0 times 12 added to that, so you only have a 0 and a 1. But this one, this is 1. You multiply by 12, added to it. This one is 1. You multiply by 12, you add to negative 15, you get a negative 3. So that is my new R2. All right, I have a little space. I can do one more. So I can get rid of this one. So from 1, I multiply by negative 1, then add to it. That's my new R1. So I will use R3 times negative 1 plus R1. That becomes my new R1. So far for the the other 2 column, 2 rows, I'm happy. So I'm just write it. So this is my R2 and R3. Now my new R1 is R3 times negative 1 added to it. This one times negative 1 added to it. Basically, I'm not changing it, but this one. This times negative 1 added to it. I got a 0. Okay, and then this one times negative 1 to that, I get a 7. That's my new R1. Almost done, right? One more step. Okay, my last step. I already see the light at the end of the tunnel. So I will need to get rid of that using this one. So my new R1 will be R2 add to R1. So R2 plus R1, that becomes my new R1. And then I keep writing, just copy. So -3 and 1. That's my R2, R3, and R1. Okay, so this add to that. So this added to it, this added to it, and this, and 4. Okay. Phew. The answer is this. X equals 4, y equals -3, z equals 1, or you say 4, -3, 1. That's how you use the matrix to solve a system of linear equations. What do you think? Again, keep in mind, this first to get that 1, and this is second to get that to be 0, and the third step to get here to be 1, the fourth step is 3 by 3, okay, and then to make here to be 0, and then to make here to be 1, and to make here to be 0, to make here to be 0, and the last one is to make that to be 0. That's the 8 steps. All right, that's all for this class.